everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're going to start with the chemistry for class 11. That has been the part 2 we have to start with. This has been the class's third and we had done your class 2, and in that we had even though started with unit 8, which has been your the redox reaction that we have to discuss here. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel so that many and maximum people can get the information at once, and you can also enjoy the video as well. Here we go, starting with the groups. This is your group 1, 2, 13, 14, 15, 16 and 17. So you go for the same. This is for this. Here we go. So for the group we will talk about element. Then we discuss about compound, and then we will discuss about highest oxidation number, state of the group element, here we go for the same, which has been the element or look at its sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. The compounded form is NaCl, MgSO4. Then we have your AlF3, SiCl4, P4O10, SF6, HClO4. Highest oxidation number of the state of the group element is your +1, +2, +3, +4, +5, +6 and +7. For the same, the oxidation number state of a metal in a compound is sometimes presented according to the notation that is given by the German chemist Alfred Stock. It is popularly known as the Stock notation. According to this, the oxidation number is expressed by putting a Roman numeral representing the oxidation number in parentheses after the symbol of the metal in the molecular formula. Thus, Ors chloride and auric chloride are written as Au first Cl and Au third Cl3. Similarly, stannous chloride and arsenic chloride are written in Sn second Cl2 and Sn4Cl4. This change in oxidation number implies the change in oxidation state, which to turn help to identify whether that species is present in oxidized form or reduced form. Thus, Hg21Cl2 is the reduced form of Hg second Cl2. The idea of oxidation number that has been invariably applied to define oxidation, reduction, oxidizing agent, oxidant, reducing agent, reductant, and the redox reaction. To summarize, we may say that about talking about oxidation. Oxidation is, as I had written in the last which is I had told you about for the last classes, that has been oxidation is an increase in the oxidation number of the element in the given substance. That is being known as oxidation. In terms of reduction, that has been a decrease in the oxidation number of the element is in the given substance that we have. For oxidizing agent, it is a reagent which can increase the oxidation number of an element in a given substance. These reagents are called oxidants here also. Reducing agent is a reagent that which lowers the oxidation number of an element in a given substance. These reagents are also called reactants. In redox reaction we have to cover up, which has been a reaction which involves change in oxidation number of the interacting species. We go further, we'll discuss here, that is we have to go further here, which is we'll talk. I write it down for you also that you can just write it down and copy it down, you will be remembering it out. Oxidation. In terms of oxidation, it will be an increase in the oxidation number of element in the given substance. Now talk about for the another one, which is the reduction. Then we talk about for oxidizing agent. So we'll go for the first reduction here, which is being a decrease in the oxidation number of element in the given substance. Talking about for oxidizing agent, it is being a reagent which can increase the oxidation number of an element in the given substance. These reagent are called as oxidants also. Now we talk about for reducing agent. For reducing agent, that a reagent which lowers oxidation number of an element in a given substance. That is being in a given substance. So these reagent are also called as reductants. Now we talk about for the redox reaction, which we have. And for redox reaction, it will be reaction which involve change in oxidation number of the interacting species. We go for the detail about it. We'll do a question here that has been of course important one. So the question has been, using stock notation, represent the following compound. Using stock notations, represent the following compounds, which has been HAuCl4, and another is Ti2O. Then we have your FeO, Fe2O3. Then we have your CuI, CuO, MnO, MnO2. These we have. So by applying the various rules for calculating the oxidation number of these desired elements in a compound, so that the oxidation number of each of the metallic element in its compound, that has been for this, it has been your Au has 3, Ti has 1, FeO, there Fe has 2, Fe2O3, it has been Fe has 3, CuI, Cu has 1, CuO, it has been Cu has 2, MnO in this, so Mn has 2, MnO2, so here Mn has 4. Where therefore these compounds may be represented as, which has been HAu third Cl4, been representing, this has been HAu third Cl4. This one has been Ti2O. Then another is Fe second O, Fe2 third O3, Cu1I, Cu second O, Mn second O, Mn4 O2. Now we talk about for the another one, which will go further, and that has been another important questions, and which just you have to justify the reaction to Cu2O plus Cu2S is give you 6 Cu plus SO2 here. So we'll discuss for the same, and of course that has been important here. So let's find it out here. The question, we go for the same. So we go for the same, that has been justify that the reaction to Cu2OS plus Cu2S give you 6 Cus plus S2 gas here is a redox reaction. Identify the species oxidized reduced which act as an oxidant and which acts as a reductant. Okay, so this is what we'll have to discuss here. And so for the same, Let us assign an oxidation number to each of the species in the reaction that of the under examinations that we have given here. For the reaction, we'll find it out. TCO2O as solid plus CuS solid, it will give you 6 Cu solid plus SO2. So for the same, it will be plus 1 minus 2 plus 1 minus 2 0, and this is plus 4 minus 2. We therefore conclude that in this reaction the copper is reduced from plus 1 state to 0 in oxidation state, and sulfur is oxidized from minus 2 state to plus 4 state. The above reaction is thus a redox reaction. And further, that is Cu2O, that is helps on sulfur in Cu2S as well to increase an oxidation number. Therefore Cu1 is an oxidant and sulfur of Cu2S, that helps of copper both in Cu2S itself and Cu2O to decrease its oxidation number. And for the same, therefore the sulfur of Cu2S is a reductant as well. Now we go further, which we'll talk about it, which is about the types of redox reaction. In the same, we'll discuss here, which is of course being the important one. Types of redox reaction. So we discuss the first type, which has been the combination reaction. In terms of combination reaction, where a combination reaction that may be denoted as in the form of A plus B will give you C, and either A and B or both A and B, that must be in the elemental form for such a reaction, that to be a redox reaction. All combustion reaction that which make use of elemental dioxygen, as well as an other reaction that involving an element other than dioxygen, that are redox reaction. Some important examples of the category that we have here, and that's the reactions we have as follows, which has been copper solid plus O2 in the form of gas. This is also being 0 plus being 0, it will give you in the presence of heat CO2 in the form of gas. This is plus 4 minus 2. Another, we have 3 Mg solid, this is in presence of 4 plus N2 gas. O, that in the presence of heat is this Mg3 N2 solid, which is plus 2 minus 3. Now for the next, we go for the same, and that we'd have to discuss here, and that has been of course important one. So we go for the same, it will be your CH4 gas plus 2O2 gas minus 4 plus 1, this is 1 0. In the presence of heat, it will be CO2 gas, which is plus 4 minus 2 plus 2 H2O, it is in the form of liquid, plus 1 minus 2 here. Now we discuss about the another one, and which is of course been important one, and that has been for the decomposition reaction, and that is of course been important here. Let's find out for the second one. We talk about for the second one, which has been the decomposition reaction. That has been the second category. In this, the decomposition reaction that are the opposite of the combination reaction, that precisely a decomposition reaction leads to a breakdown of a compound into the two or more components, at least one of which that must be in the elemental state. Example of this class of the reactions that we have here is being as follows, and that what we'll have to discuss as well. It's been 2 H2O liquid will give, in the presence of heat, is will 2H2 gas plus O2 gas here, 0 0, and of course plus 1 minus 2. The another reaction we have is 2NaH, which is plus 1 minus 1 solid in the presence of heat, 2Na solid, this is 0 plus H2 gas. This has also been 0. The another we talk about for it, 2KClO3 solid, which is +1 +5 -2. In the presence of heat, it will 2KCl +1 -1 solid +3O2 gas. It may carefully be noted that there is no change in oxidation number of oxyhydrogen in methane under the combination reaction, and that of the potassium is in potassium chloride in reaction. This may be also be noted here that all the decomposition reactions are not redox reaction. For example, the decomposition of the calcium carbonate is not a redox reaction. So that has been in the form of CaCO3 solid in the presence of heat +2 +4 -2 will give you CaO solid +2 -2 and plus CO2 gas, which is +4 -2. That we talk about it. Now further it will be going to end up with, and we'll discuss the rest of the class in the next coming class, and that will start discussing about the displacement reaction, and then after that then we'll discuss about another one, which is about your disproportional reaction, and then after that we'll do the numericals and balancing of redox reaction, and many more we have to do with half reduction reaction, half oxidation reaction as well. But before ending it up, please go ahead with like, share and subscribe our channel, so that many maximum people can get the information at once, and you can also enjoy the video as well. But other than this, we had done your sociology and software engineering, even though we had done your we had done your that is chemistry for class 11th, that is of part 1. We will talk about it, and the little part 2 chemistry class 12th part 1 we had done, where in that we had done your unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9, as well as the conversions, logarithms and antilogs as well. We even though had done we started with physics part 1 for class 11th as well, where we had done your physical world, and we are dealing with units and measurement. Other than this, we are dealing with CPNST, where we had completed unit 1, unit 2, and we are in unit 3. In terms of it, we are dealing with ER diagram, we are dealing with English vocabulary, we are dealing with PHP interview questions, we are dealing with general knowledge and important facts about the countries as well. We had done your reasoning. In that we had done your general mental ability and the logic reasoning of verbal reasoning. In non-verbal reasoning, we had done general mental ability, the logic we had done series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, dot situation, constructions of squares and triangles, figure formation analysis, practice question set as well. Coming towards quantitative aptitude, here we had started with arithmetical ability. In that we had done which has been the operations on numbers, SCF and LCF of numbers, decimal fractions, simplifications, square roots and cube roots, problems on numbers, problems on ages, surds and indices, percentage, profit and loss, ratio and proportion that we had started with. Other than that, we talk about for the chemistry here, that has been for chemistry part 1 we had done the unit 1, which is some basic concept of chemistry. Unit 2 is your structures of atom. Unit 3 is classification of element and periodicity in the properties. Unit 4 is chemical bonding and molecular structure. Unit 5 is the states of matter. Unit 6 is thermodynamics. Unit 7 is equilibrium. In terms of unit 8, which we had started with, that has been the redox reaction. Here in the redox reaction we had cover up about the classical ideas of the redox reaction, oxidation and reduction reaction, redox reaction in terms of electron transfer reaction, oxidation number, redox reaction and electrode processes as well. In this next we'll have to discuss about many more, which has been about the unit 9, which has been hydrogen, that has been position of hydrogen in the periodic table, dihydrogen H2, preparations of dihydrogen H2 and properties of dihydrogen hydrides, and water, hydrogen peroxide, H2O2, heavy water, D2O, and dihydrogen as a fuel. In unit 10 we have to cover the S block element, which has been group 1 element, alkali metal, general characteristics of the compound of the alkali metal, anomalous properties of lithium, some important compounds of sodium, biological importance of the sodium and potassium, group 2 elements, alkaline earth metal, general characteristics of the compounds of the alkaline earth metal, anomalous behavior of beryllium, some important compounds of calcium, biological importance of the magnesium and calcium as well. In terms of Unit 11, we have to cover up the P block element, which has been group 13 element, the boron family, important trends in the anomalous properties of boron, some important compounds of boron, uses of boron and aluminium and their compounds as well. After talking about that, we have to cover up group 14 element, the carbon family, important trends and anomalous behavior of the carbon, allotropes of the carbon, some important compounds of the carbon, and silicon. In terms of Unit 12, we have to cover up the organic chemistry, which has been some basic principles and technique, which has been the general introduction, tetravalence of carbon, shapes of organic compound, structural representative of the organic compound, classification of the organic compound, nomenclature of the organic compound, isomerism, fundamental concepts in the organic reaction mechanism, methods of purification of the organic compound, qualitative analysis of the organic compound, quantitative analysis as well. In Unit 3, we have to cover up the hydrocarbons, which is in the classification, alkane, alkene, alkynes, aromatic hydrocarbons, and carcinogenicity and toxicity as well. In terms of it, we have to cover up another one, which has been your Unit 14, which has been the environmental chemistry, where we have to cover up the environmental pollution, atmosphere pollution, water pollution, soil pollution, industrial waste, as well as strategies to control the environmental pollution, green chemistry here as well. So we have to cover up many more in the next coming class, and that will discuss here. As I told you, many more we have to discuss on the same behalf of it, where there are many going to be the reactions as well as in terms of it we have to cover up some of the questions. So I will just talk about the questions here, so that you will get to know about it, that what we'll have to cover up here. In the same phase, the question that you have to assign the oxidation number to the underlying added elements in the each of the element, where you have your Na H2PO4, where P is underlined, NaHSO4, which S is underlined, H4P2O7, where P2 is on underline, K2MnO4, where Mn is underlined, CaO2, that is O is underlined, NaBH4, that is B is underlined, H2S2O7, S2 is underlined, KAlSO4 twice dot 12 H2O, where S is underlined. This has been the first question here. So now talking about second question, what are the oxidation number of the underlined elements in each of the following, and how do you rationalize your results, where we have Ki3, H2S2O6, H2S4O6, Fe3O4, CH3CH2OH, CH3COOH. In Ki3 I is underlined, H2S4O6 S is underlined, Fe3O4 Fe is underlined, CH3CH2OH, where C in both is being underlined, and CH3COOH, where C in both in underlined here. Now we talk about for the another one. The another question is justify the following reaction as a redox reaction, where CuO in solid state plus H2 that is in the gaseous state, it will give you CuS plus H2O, that is in the form of gas. So next as equation we have Fe2O3 solid plus 3Co gas, that gives you 2Fe solid plus 3CO2 gas. Another 4BCl3 gas plus 3LiAlH4 solid gives 2B2H6 gas plus 3LiCl solid plus 3AlCl3 solid. Another 2K solid plus F2 gas give you 2K plus F minus solid. Next 4NH3 gas plus 5O2 gas give you 4NO gas plus 6H2O gas here. Now we're gonna end up with it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.